Now that we know how to solve systems of linear equations, let's now consider solving application problems where we will be using systems of linear equations. So what we really want to do is to translate the verbal description into a system of linear equations. The first thing we need to do in any application problem is to read the problem, all right, identifying the known as well as the unknown quantities, and then using variables to represent the unknown quantities. So let's see what we have to do in this problem. A chemist needs to mix an 18% acid solution with a 45% acid solution to obtain 12 liters of a 36% acid solution. How many liters of each of the acid solution must be used? All right, so the first thing we need to do is to represent the unknown quantities. All right, so we're going to let X represent the number of liters of the 18% acid solution, or the number of liters of the 18% acid. Y we're going to let represent the number of liters of the 45% acid solution, 45%. All right, so now what do we want to do? Let's see what kind of system we can establish here. All right, so we want to write a system. But you might want to engage in more analysis of the situation. All right, and one way to do this is to, well, I like to create a table just to tabulate what we know. And this is always a good way. All right. So this, in the first column, I'm going to label as the solution. All right, and we have an 18% acid solution. So let's identify this as the 18% solution. And we also have a 45% acid solution. So let me identify this solution as the 45% acid solution. And we want to obtain 12 liters of a 36% solution. So 36% mixture is what we want. All right. And now let's, how many liters? Number of liters in each. All right, so the number of liters in the 18% acid solution is X. All right, so let X represent the number of liters of the 18% solution. And the number of liters of the 45% acid solution is Y. All right, Y liters. All right, and we want to obtain 12 liters in the mixture. So that's going to be 12. All right, we know that the mixture, the final mixture, will contain 12 liters. All right. All right, what else do we need? All right, let's see here. We want the percent of the acid solutions. All right. So in the first case, the percent is going to be 18 because 18% is 0.18. Let's write it as a decimal. So be sure to make sure that you convert that correctly. 45, the percent of the acid solution is 45%, so that's 0.45. And in the final mixture, it is to be 36%. So I'm going to have 36%. Now if we multiply the number of liters in each by the percent of each acid solution, we will obtain the amount, the desired amount of acid solution. All right? So if we multiply, so we get x times 0.18 is 0.18x, and y times 0.45, we're going to get 0.45x. And for the mixture, we have what? 12 times 0.36, or 0.36 times 12. All right, so that's what we have. That's our analysis of the problem. Now we can write the system. All right, the system now. How do we write the system? So we know that we have a total of how many liters? 12. So that's going to be x plus y, the number of liters in the 18% solution, plus the number of liters in the 45% acid solution. And we know that we will have a total of 12 liters. So x plus y is equal to 12. What else do we know? We know that the amount of acid solution in each case, all right, is going to be the amount for the 18% acid solution will be 0.18x plus the amount of acid solution in the 45% solution is going to be 0.45y is equal to the mixture. All right? And I hope I see that, I hope I said y here, not x. So that's 0.45y. Now, the final mixture will contain 12 liters of a 36% acid solution. So how do we write this? This is going to be 0.36 times 12. All right, so this is the system. We've translated the verbal description into a system of linear equations. Now we need to solve this system of linear equations. All right? All right, so we want to solve. Let's solve. All right, so let's take the first equation. I'd suggest that we use substitution, the method of substitution, to solve this system. So I can take the first equation, x plus y is equal to what? 12, and express y in terms of x. So we get y is equal to 12 minus x. So that's y. Y is 12 minus x. All right, so we go now to the second equation in the system, 0.18x plus 0.45 times y, but we're going to replace or substitute 12 minus x for y. So we get 0.45 times 12 minus x is equal to 0.36 times 12. All right, to solve this equation, you need your calculator if you like. All right, so what are we going to get here? We get, on the right-hand side, what do we get? So your assignment is to check, to make sure that you obtain this as your third step, after multiplying and simplifying by combining like terms, you get a negative 0.27x is equal to a negative 1.08 on the right-hand side. All right, and if we were to solve this, you get that x is equal to a negative 1.08 divided by a negative 0.27. Using your calculators again, you should obtain that x is equal to 4. All right, so x is 4. So we know 4 is x. What is y? We can go back to this, and we know that y is 12 minus 4, which is what? 8. All right, so we can answer the question. We have x is equal to 4, y is equal to 8. And the question is, how many liters of each of the acid solutions must be used? So we can conclude that the mixture will contain 4 liters of the 18% acid solution and 8 liters of the 45% acid solution. Okay, another homework problem. This time, the homework problem is an application problem. So again, I would like for you to solve the application problem where you will use systems of equations to solve this application problem. So you are to post your solution to the discussion board. The first person with the correct solution will receive extra credit. The solution must be posted by May 13th. Okay, the next application is an application from business. All right, so let's consider finding the break-even point. This is a problem from business, functions of business, break-even analysis. Suppose that a company produces and sells X units of a particular product. Its revenue is the money generated by selling X units of the product. Its cost is the cost of producing X units of that product. A company produces and sells X units of a product. All right, so let's see what that means. All right, so if a company sells and produces and sells X units of a product, then we can talk about the revenue. All right, the revenue function is going to be, let's use R for revenue and express the function as a function of X. So the revenue function can be defined as the price per unit sold, all right, times what? The number of units sold, times X. All right, so that's the revenue. The cost, all right, so the cost function, let's represent the cost as a function of X. All right, where X, of course, as we said, is the number of units produced and sold. All right, so the cost function is going to be a fixed cost, whatever the fixed cost of the company, the fixed cost plus the cost per unit, all right, produced. How much did it cost to produce each unit times the number of units produced. All right, so here we have the revenue function and the cost function. Now let's look at an application problem where we have to find All right, what we're interested in is the break-even point. Find the break-even point. All right, so let's look at that. All right, finding a break-even point. All right, let me just first of all remind you that the point of intersection of the graphs of the revenue and cost functions is called the break-even point. That point of intersection where the two graphs would intersect. The x-coordinate of the point reveals the number of units that a company must produce and sell so that the money coming in, which is the revenue, is equal to the money going out, which is the cost. And the y-coordinate of the break-even point gives the amount of money coming in and going out. All right, so knowing that, we can find the break-even point for the given problem here. A company that manufactures running shoes has a fixed cost of $300,000. Additionally, it costs $30 to produce each pair of shoes. They are sold at $80 per pair. All right, so let's write the cost function C of producing X pairs of running shoes. So the cost function, C of X, we want to denote it as C of X, and we define the cost function to be what? The cost function was the fixed cost plus the cost per unit to produce a pair of shoes times the number of running shoes produced. So in this case, the fixed cost is given to be $300,000. So we have $300,000 plus what? All right, plus $30 to produce each pair. So that's 30 times the number of pairs of shoes produced, which is X. So the cost function is represented by the function C. C of X is equal to 300,000 plus 30X. In part B, we want to write the revenue function R from the sale of X pairs of running shoes. All right, so we recall that the revenue is the price per unit sold, and the running shoes were sold at what? $80 a pair. So we have R of X, the revenue function expressed as a function of X. In this case, the revenue is going to be $80 times the number of pairs of shoes sold. So let's call it X. So that's the revenue function, 80 times X. Okay, part C. Determine the break-even point and describe what it means. All right, you recall that the break-even point is when the revenue is equal to what? The cost. All right, so I want to equate the two functions. So in this case, what do I have? The revenue is 80X, and the cost is 300,000 plus 30X, right? So what do we have? We merely just need to solve for X. If we solve for X, 80X minus 30X is going to be 50X is equal to 300,000, and X is going to be what? 50 divided into 300,000, which is 6,000. All right? All right, so 6,000. So 6,000 pairs of running shoes must be produced and sold in order to break even. All right? So If I now evaluate the cost function as 6,000, C of X, X is 6,000, what do we get? We get 300,000 plus 30 times 6,000, we get 480,000. So the break-even point, that's just the break-even point is the point, all right, X is 6,000 and Y is 480,000. All right, so this is the break-even point. So that means that the company will need to make 6,000 pairs of shoes and earn $480,000 to break even.